afternoon, dear students. We are on the CEC Gurukul lecture and we are in the series of the electronic circuit, and today's lecture we discuss the solenoid. That is the one of the electronic components used in the electronic circuit. Then solenoid is a coil of, basically a coil of wire. These generate a magnetic field when stream a force over a magnetic element. So on the screen you are seeing that this is a solenoid which is having a helical coil on the base, and there is a base and it is having a two terminal. This is the solenoid. So in the solenoid, a solenoid basically the coils of wires, as you are seeing here. This is a coil of wires on the base, and this generate a magnetic field which stream a force over a magnetic element. So this happens when we apply the electric current to the solenoid. When we apply the electric current to the solenoid, then it generates a magnetic field which stream a force over a magnetic element. Now solenoid helps the energy to convert into the action instantly. So therefore these work decently for these application which require immediate action in the electronic circuit. So solenoid, if we talk about the solenoid in the physics term, the solenoid basic terms for a coil of wire that we use as an electromagnet in the electronic circuit. So we also refer to the device that can convert electrical energy into the mechanical energy as a solenoid. So if we talk about the solenoid, definition of the solenoid that converts the electrical energy into the mechanical energy as a solenoid. So actually it generates a magnetic field for creating linear motion from the electrical current with the use of magnetic field. It generates a magnetic field for creating the linear motion from the electric current with the use of the magnetic field. Solenoid are simple electrical components that it has many uses in the daily life. The term itself is derived from the Greek word solon, which illustrates a channel or a pipe. Solon means a pipe, and the second part of the name is taken from the Greek name iod, that is refers to the outline. It means channel outline. Basically it is component in the form of a pipe. Here we are having a pipe and the wire coil is rounded. The solenoid is used in a variety of application. So there are the numerous type of solenoid design available. Each of them has their own properties and that make is useful in many precise applications. The various design of these components do not change their necessary operating features, and the designing of the solenoid can be done according to its use in the different ways. So generally solenoid works as general electrical principle, but the mechanical energy of this device is distributed in the different ways in the different design. So this solenoid works in the general electric principle, but the mechanical energy has device distributed in the different ways in the different. So on the screen we are having the solenoid device. You see here, this is the coil, round coil, and these are integral path for the Ampere's law. You see here the current is passing through it and it is placed in the magnetic field. I current is passing from the one side and output we can take on the other side. A particular length of solenoid here defined, that according to its use the length is adjusted. So the basic application of the solenoid are to be used in the switch for the power, like the starter in like the starter in any vehicle, a valve in a sprinkler like system. It is also an example of here. You see on the right hand side we are having some type of the solenoid. Like how does the solenoid work? I discussed about solenoid is a coil of the wire, and it is in the shape of corkscrew or the wraps around the piston. So, on the other way it is made up of the iron, and on that iron a coil is round on it. So, likely it is all the electromagnets, that electromagnet work as a electromagnet, and that is placed in the electronic circuit. When the electric current passes through the wire, the magnetic field generates in the solenoid. When we are having a two terminal, when we pass the electric current in this coil, then the magnetic field generated, and more importantly, electromagnet are better as compared to the permanent magnet. Why? Because they can be switched on and off by the removal of the electric current or by the application. So, these electromagnets are better as compared to the permanent magnet, as we can switch on and off in this electromagnet. Now, it makes them more useful like switches and valves, and also allows them automated entirely. Means we can control it, and its on and off control can be done in very easily in these electromagnets. So, they are used in the switches and as well in the valves. Likewise, all other magnets and activated solenoids magnetic field has both the positive and the negative poles that result in attracting or repelling material sensitive to the magnet. As a solenoid having the positive and negative poles, so it can attract or repel the material, and that makes it a sensitive instrument. So, there are different type of solenoid. We talk about the electrical solenoid. The starter solenoid in an automobile ignition system acts as a relay, and we know the relay, this brings the metal contacts at a place that result in closing a circuit. When the motor car ignition activates, the starter solenoid receives a small electric current basically by the turn of the key, and you now we will well understand that in the starting of the key we are having a solenoid. As we just on the key, as we turn the key, the motor will start. It means this solenoid used in to produce the ignition, and in the motor car a small ignition activates in the motor car to start the motor. So, like a motor car, like a vehicle we can start. So, in the vehicle we use a solenoid at the end of the key. So, then the solenoid's magnetic field pulls on the contactor, and this process closes the circuit between the starter motor and the car battery. It will complete a circuit from the starter motor and the car battery. And a little bit ignition will given to the motor, starter motor, and then there is a connection, there is a contact between the car battery. So, in order to maintain the circuit, the starter solenoid needs a constant flow of electricity. So, when the engine starts, then the solenoids are not most active because the engine is self-powering. So, this solenoid is used to start the ignition and start the motor. After that, the engine work, and it is a self-working. So, what is the use of the solenoid? Solenoids are extremely useful and incredibly versatile. We can find them almost everywhere, from the doorbell to the paintball guns, and even in the automated factories equipments. In the doorbell, the audible sound generates because the metal piston strikes with the tone bar, and this magnetic field of the solenoid is the force that moves the piston, and this force receives the electric current when we ring the doorbell. Like the functions of the solenoid, as the electric current passes through the solenoid coil, the creation of magnetic field takes place, and we see that when we pass the electric current in the solenoid, the magnetic field generated, and the magnitude strength is measured by the number of the coils are featured by the solenoid. So, function of the solenoid, the armature in the solenoid is movable, therefore, a voltage passes through the coil and the armature increases the flux linkage by its movement, and this happens due to the closing of the air gap between the two cores, so which are movable on the armature. So, they come with the spring so that the voltage is switched off to the solenoid and then it gets back to its initial position. So, in the uses of the solenoid, it is useful in many applications, from the appliances to the electronic hobbies, like in the electronic circuit generally use the solenoid for the purpose of the electromagnet, and they are usually found in the application that require a feature that can automatically turn the appliances on and off. For example, an electric touch or an engine kill switch commonly used in the motorbike nowadays, which is based on the solenoid. Different type of the solenoids, there are the various type of the solenoids available in the market, and they differ in terms of their material, design and function. According to the use, they are designed and they work properly, and the what material we use where we are using that solenoid. But all kind of solenoids depends on the same electrical principles. And what type of the different types of the solenoid are? AC laminated solenoid, second is the DCC frame solenoid, and third is the DCD frame solenoid, and then that is the linear solenoid, then the rotary solenoid. So, there are the different type of the solenoid: AC laminated solenoid, DCC frame solenoid, DCD frame solenoid, linear solenoid and rotary solenoid. So, AC laminated solenoid is famous for the amount of the force that can be performed in their first stroke, like they can also use a longer stroke than a DC solenoid. So, they are obtainable in the several different configuration and the ranges. These type of solenoid will produce a clean buzz when they are being used. On the right hand side, we are having a different type of the solenoid. This is the AC laminated solenoid, and this is performed on the first stroke, means when we give it then it work. Second is the DCC frame solenoid, and is only the uses only a frame, and C frame solenoid uses only a frame and formed like a letter C. You see here that the letter C, that is why it is called the DCC, which is covered around the coil. And this type of solenoid has a extensive range of the different application. Even though they are famous in the DC configuration, they also designed to be used with the AC power supply. Next type is the DCD. You see, just like the D frame we are using, that's why it is a DCD frame solenoid, and gears have a two-piece frame that is covered around the coil, and these are used in the several different applications like industrial application also. And like the C frame, this solenoid can also be designed in the AC alternatives for applications when the properties of the AC solenoids are more attractive than the DC solenoid. So, now next is the linear solenoid. You see here that this type of the linear solenoid, this kind of the solenoid is more familiar with the most people, and we use these use in many gadgets, electronic gadgets. These are capable of using a pulling or pushing the forces on the mechanical devices. In the doors, we just use this type of when we use a touch screen in the door closers, then we use this type of the mechanical devices, can be utilized for a variety of metering tasks. And these solenoids are used in the different applications. For the instance, the solenoid on the starter devices of a vehicle, which includes a motor, whereas the electrical current flows through the solenoid, and then it will move in the linear fashion and get contact together. When the two contacts are getting together, and they let power to flow from the battery supply to the different components of the automobile, and the automobile start. First we give the ignition to the starting point. The best application of the solenoid is the electric lock, and we use this in the electric lock. So in the doorbells, in the bolt of door, when the lock is attached to the bolt on a door, then we use this type of the solenoid, and it can immediately protect a door sufficient to hold up to the great deal of the violence. And other type is a rotary solenoid. Rotary solenoid is a good example of the mechanical force, and which can be used in the different methods to make easy of an automatic control process, and quite easy to make the life easier. So in this type of the solenoid, there is a similar coil and core design, though it is somewhat changed. In the rotary solenoid, a disc is used instead of the solenoid being a simple device with a core and the coil. And the body of the solenoid is lined up and grooves with the ball bearing and used to make the easy motion. You see here, and this type of rotary solenoid, and the triggering the solenoid makes the core to be drawn back into the coil. This force is converted into a rotation force of the disc. Most of the devices are also inbuilt with a spring, and this type of solenoids are used. When the power supply is detached from the solenoid, the spring makes the core to be drawn out of the coil, releasing the disc and transferring it back to its unique position. So it is just like a similar in electrical devices. These tool happens to have been developed as a security devices. Solenoids are just used in the security devices in the ignition. So this type of rotary solenoid, this product first was used in the World War II as a way to enhance the durability of the devices uses in the bombs. Nowadays, these type of solenoid is journal electrical component that is very appropriate to utilize trying the industrial environment, in the door steps, in the doorbells. What are the applications of the solenoid? So solenoid is an essential coil of wire that is used in the electromagnets, inductors, antennas, valves, etc. So the application of the solenoids differ in the numerous type of the medical, locking system, industrial use, bottom line, automobile solenoid application. Solenoid is used to control the valve electrically, as we see. For example, the solenoid core is used to apply the mechanical force to the valve, and that's why it works, and instantly it works. These can also used in particular type of the door locking system, which use an electromagnet and offer a very secure closure. Solenoid is used in many different appliances and products like the computer, printer, fuel injection, gear used on the car, and in the various industrial settings. The main advantage of the solenoid is whenever an electricity is applied, the reaction of the solenoid is immediate. Means when we apply the electric current to the solenoid, it immediately response give the response, and the quick response we get through this solenoid. That quick response is one of the most significant factor in resolving the applications of the solenoid. So this solenoid have a many application in the various circuit. The another electronic component that we use in the electronic circuit is the magnetometer. It is also very important when we just preparing electronic circuit for any gadget. So we use the magnetometer. What is this magnetometer? Magnetometer are extensively used in the various applications like geographical survey, archaeological survey, metal detector, space exploration, etc. to detect the mineralization and the geological structure. Mineralization and the geological structure. Then we use the magnetometer. In the oil and gas industry, these meters play an important role for the directional drilling process. These meters are available basically based on the type of application like land, airborne, marine and the microfabricated atomic magnetometers. So, magnetometers are used to measure the strength of magnetic field and in some cases direction of the field. So, what is the magnetometer? That magnetometer is used to measure the strength of the magnetometer. Strength of the magnetic field we can measure through this magnetometer, and sometimes we can find out the direction of the magnetic field through this magnetometer. So, both the purpose we can solve, we can find the strength as well as the direction of the magnetic field by using the magnetometer. These come under the scientific instruments, and a sensor that is attached in this device measure the flux density of the surrounded magnetic field around it. So, it can measure the around the magnetic field. The magnetic flux density is proportional to the magnetic field strength. So, the output directly gives the intensity or the strength of the magnetic lines. So, Earth is surrounded by the lines of the flux which vibrates at the different frequency depending on the locations. So, any object or anomaly which distorts this magnetic field is detected by the magnetometer. So, these devices can detect the two type of the magnetism. First is permanent and second is the temporary magnetism. In the temporary magnetism, the magnetically susceptible material acquires a magnetic field from the external field. So, the higher the material magnetic susceptibility, stronger is the induced magnetic field. This type of measurement is used in archaeological processes. Some of the sources of the permanent magnetism are like iron and other metals useful while measuring the magnetic field strength. However, these devices are also making use of the magnetic properties of the nuclei of the atom. It means through the magnetometer we can measure the magnetic field strength as well as the direction of the magnetic field strength. Moreover, we can find out the magnetic properties of the nuclei of the atom. How many types of magnetometers are? Magnetometers are divided into two basic types. First is the scalar magnetometer and second is the vector magnetometer. Now, the scalar magnetometer measures the scalar value of the magnetic flux intensity with very high accuracy, and these are again differentiated as a proton precession and overhaul effect. And ionize the gas magnetometer. A vector magnetometer measures the magnitude and the direction of the magnetic field. These are divided into the various types like scalar are divided into various types like the Hall effect and magnetoresistive, flux gate, search coil, squid and SERF magnetometers. All these type of magnetometers are discussed briefly further. What is a scalar magnetometer? And that is a proton precession magnetometer. In the scalar magnetometer there is a proton precession magnetometer. Proton precession magnetometer, and it is used in the nuclear magnetic resonance in the NMR to measure the resonance frequency of the protons in a magnetic field. So, a polarizing DC current is passed through the solenoid that creates the high magnetic flux around the hydrogen rich fuel like the kerosene, and that can measure the, and some of these portion of the aligned with this flux when the polarizing flux is released. So, the frequency of precession of the proton to the normal alignment can be used to measure the magnetic field. Now you see on the screen, this is a one type of magnetometer. That is how we can measure the various value by using the different sensors. So they are having a many parts like battery relay, like control electronics, like we are having a paired uh, control counter, and we are having a halt where different values, and this is a one type of magnetometer. Another type is the Overhauser effect magnetometer, and this type in this type of magnetometer, protons are coupled to the nuclei of the liquid, and the precession frequency is linear with the magnetic flux density, and thus can be used to measure the field strength, and it requires a less power consumption and has a faster sampling rate as compared to the previous one. And then another is ionized gas magnetometer, and then these are the scalar magnetometer. This is the scale. This is a one type of the ionized gas magnetometer. So here we are having a various type of magnetometer. Further, we will discuss the vector magnetometer, where we will discuss the different type of the vector magnetometer and how they are used in the next lecture. Thank you very much.